Mars, the red planet, has always fascinated us. Its striking red hue, visible even to the naked eye, has sparked curiosity and wonder for generations. For centuries, humans have looked up at this bright point of light in the night sky and wondered, could there be life on Mars? Ancient civilizations named it after their gods of war, and early astronomers meticulously charted its movements across the sky. But life as we know it needs water. Water is essential for all known forms of life, serving as a solvent, a means of nutrient transport, and a medium for biochemical reactions. Could a planet as cold and dry as Mars ever have been a place where water flowed? The surface of Mars today is barren and desolate, with vast deserts and rocky plains that seem inhospitable to life. Even in the 19th century, astronomers using early telescopes noticed something intriguing about Mars. They observed seasonal changes and peculiar surface features that hinted at a dynamic planet. They saw white patches at the poles that grew and shrank with the Martian seasons. These polar ice caps, similar to those on Earth, suggested the presence of frozen water. Could these be ice caps like on Earth? If so, it would mean that Mars had at least some water, albeit in frozen form. Some astronomers even believed they saw lines crisscrossing the planet's surface. Lines that they thought might be canals built by intelligent beings. These so-called canals fueled speculation about a once thriving Martian civilization. While the idea of Martian canals turned out to be wrong, the possibility of water on Mars captured our imaginations. The notion that Mars might have had liquid water in its past opened up exciting possibilities for the existence of life. The search for Martian water became a key part of our quest to understand if we are alone in the universe. Space missions were launched, equipped with sophisticated instruments designed to detect signs of water and life. Could this red, dusty planet hold the secret to life beyond Earth? The discovery of water on Mars would be a monumental step in answering this age-old question. The answer we would discover lay buried in Mars's ancient past. Geological formations and mineral deposits on the Martian surface provided clues to a wetter, more hospitable environment billions of years ago. Scientists found evidence of ancient river valleys, lake beds, and deltas, indicating that liquid water once flowed freely on Mars. These features suggest that Mars had a climate capable of supporting liquid water for extended periods. Sedimentary rocks and minerals that form in the presence of water were discovered, further supporting the idea of a watery past. Mars rovers drilled into the surface, analyzing soil and rock samples to uncover the planet's history. The thin Martian atmosphere, composed mostly of carbon dioxide, also holds clues to the planet's past. Weather patterns and dust storms observed today may be remnants of a more dynamic climate in Mars's history. As we continue to explore Mars, each new discovery brings us closer to understanding the planet's complex history. Future missions aim to uncover more about Mars's past, its potential for habitability, and the possibility of life. The dream of one day colonizing Mars and making it a second home for humanity drives our exploration efforts. Understanding Mars's watery past is crucial for planning future human missions and ensuring the survival of life on the red planet. Mars, with its mysterious past and potential for future exploration, remains a focal point in our quest to understand the universe. The red planet continues to captivate our imaginations and inspire us to reach for the stars. As we look up at Mars in the night sky, we are reminded of the endless possibilities that lie beyond our own world. The story of Mars is far from over, and each new discovery brings us one step closer to unraveling the mysteries of the red planet. As telescopes improved, astronomers could see Mars in greater detail. The lines thought to be canals turned out to be optical illusions. However, other features hinted at Mars' watery past. Huge channels, too large to be mistaken for anything else, scarred the planet's surface. These channels, some stretching for thousands of miles, looked just like riverbeds on Earth, only much larger. They suggested that vast amounts of water once flowed across the Martian surface. But when did this happen? And what happened to all that water? The answer would have to wait for the space age and the arrival of robotic explorers sent from Earth. These missions would reveal a planet shaped by ancient floods and long-lost lakes. In the 1970s, NASA's Viking missions gave us our first close-up look at the Martian surface. The Viking orbiters sent back stunning images of vast canyons, dry riverbeds, and what appeared to be ancient lake basins. These images provided the first concrete evidence that Mars was once a very different place. The Viking landers, meanwhile, analyzed the Martian soil for signs of life. While the results of those experiments are still debated today, the Viking missions revolutionized our understanding of Mars. They showed us a planet shaped by ancient water, a planet that might once have been warm and wet enough for life to exist. Section 4. Spirit and Opportunity roving through ancient waterbeds. In the early 2000s, NASA embarked on a groundbreaking mission to explore the Red Planet. They sent 2 robotic geologists to Mars. The rovers Spirit and Opportunity. These twin rovers were tasked with a monumental mission to uncover the secrets of Mars' past, particularly its watery history. These rovers were meticulously designed to traverse the rugged Martian terrain, equipped with state-of-the-art instruments to analyze rocks and soil. Their primary goal was to explore the Martian surface and search for more evidence of past water. They were our eyes and hands on a distant world, tirelessly working to gather data and send it back to Earth. And they found it in abundance. The discoveries made by Spirit and Opportunity were nothing short of revolutionary. They provided compelling evidence that Mars was once a very different place, with conditions that could have supported life. Spirit, for instance, found evidence of ancient hot springs, suggesting that water, and perhaps even life, might have existed below the Martian surface. These hot springs could have been a haven for microbial life, providing the necessary warmth and nutrients. Opportunity, meanwhile, discovered layers of rock that could only have formed in the presence of liquid water. These sedimentary rocks told a story of ancient lakes and rivers, painting a vivid picture of a Mars that was once warm and wet. It even found small round blueberries made of a mineral called hematite, which often forms in water. These tiny spheres were scattered across the Martian surface, further evidence of the planet's watery past. Spirit and Opportunity's discoveries painted a picture of early Mars as a much warmer and wetter place than it is today. They revealed a planet that was once dynamic and potentially habitable, with environments that could have supported life. They showed us a planet where water once flowed freely, carving channels, filling lakes, and perhaps even supporting life. The evidence gathered by these rovers has been crucial in shaping our understanding of Mars and its potential to harbor life, both in the past and possibly in the future. Their legacy continues to inspire future missions and the quest to uncover the mysteries of the Red Planet. Section 5. Mars, Frozen Secrets, Ice at the Poles and Beyond. Mars, the 4th planet from the Sun, has long fascinated scientists and space enthusiasts alike. One of the most intriguing aspects of Mars is its ice, which holds many secrets about the planet's past and potential for future exploration. While most of the water on Mars seems to have vanished long ago, there is still plenty of ice on the planet today. This ice is not just a remnant of a bygone era, but a key to understanding the Martian climate and geology. The presence of ice suggests that Mars once had conditions that could support liquid water and possibly life. The Martian poles are covered in ice caps that grow and shrink with the seasons. These seasonal changes are similar to the polar ice caps on Earth, indicating that Mars experiences significant climatic variations. The polar ice caps are a dynamic feature of the Martian landscape, expanding during the cold seasons and receding when it gets warmer. These ice caps are made mostly of water ice, but they also contain frozen carbon dioxide or dry ice. The presence of dry ice is particularly interesting because it sublimates directly from a solid to a gas, skipping the liquid phase. This process contributes to the seasonal changes observed at the poles and affects the Martian atmosphere. But the ice on Mars isn't limited to the poles. Ice can be found in various regions across the planet, including areas far from the polar regions. This widespread distribution of ice suggests that Mars has a more complex climate history than previously thought. In 2002, the Mars Odyssey orbiter detected large amounts of water ice just below the surface at high latitudes. This discovery was groundbreaking because it provided direct evidence of subsurface ice, which had been theorized but not confirmed until then. The Mars Odyssey's findings have opened up new avenues for research and exploration. This ice is thought to be the remnants of ancient glaciers or perhaps even a frozen ocean that once existed on Mars. The idea of a frozen ocean is particularly exciting because it implies that Mars may have had a more Earth-like environment in its distant past. Studying these ancient ice deposits can provide valuable insights into the planet's geological history and its potential to support life. The discovery of so much ice on Mars has huge implications for future human exploration. Ice is a critical resource for any long-term mission to Mars, as it can be used for drinking water, oxygen production, and even as a source of hydrogen for rocket fuel. The ability to utilize Martian ice could make human settlement on the Red Planet more feasible and sustainable. This ice could be used as a resource for drinking water, oxygen, and even rocket fuel. By extracting and processing the ice, future astronauts could create a self-sustaining environment, reducing the need to transport large quantities of supplies from Earth. This capability would be a game-changer for Mars exploration, making it more practical and cost-effective. Section 6. The mystery of the recurring slope lineae. In recent years, scientists have observed something truly remarkable on Mars, what appear to be seasonal flows of liquid water. These flows, known as recurring slope lineae, appear as dark streaks that lengthen down slopes during the warm season and fade away during the colder months. While the exact nature of these flows is still debated, the leading theory is that they are caused by salty water melting from the Martian soil and flowing downhill. The salt in the water would lower its freezing point, allowing it to remain liquid even in the frigid Martian environment. If these flows are indeed liquid water, they would have major implications for the search for life on Mars. After all, where there's water, there could be life.